Hello, Math 1B. This is the third lesson of remote learning. We did exponent properties for the first two lessons where we talked about how to multiply and divide expressions that involve positive exponents, negative exponents, and zero exponents. Today we're going to be talking about how you add, subtract, and distribute monomial expressions into polynomials. So the only difference is you will not be having to deal with negative exponents here, and then you have to understand the concept of how do I divide something like x and x, and how do I combine them through addition and subtraction. It's a little different. I think you'll pick up on it, though, through these next four examples. So here's our first one. Bottom line is we are taking one polynomial, subtracting another, and then adding a third one on the tail end of that. So polynomials are basically expressions that don't have negative exponents in it and don't have fractions with variables on the bottom parts of them. So when you see parentheses, you should be thinking distributive property, which means whatever is nested on the outside of the parentheses, you are going to take that and multiply it by all the parts inside the parentheses. So when you see nothing in front, it's sort of like there's an implied constant of 1. Just like if you see a minus right in front of here, it's almost like, hey, there's a negative 1 in front of this group. And if you see a plus there, it's like saying there's a positive 1 in front of there. So when I take 1 times anything, it just gets rid of the parentheses and changes nothing inside. So with this first group, it's just going to be a positive 8 minus 1x squared minus 3x. Because that's what happens when you multiply by 1. Multiplying by a negative 1, though, is going to change the sign of everything inside of the parentheses. So negative 1 times 3x squared is minus 3x squared. Negative 1 times negative 4x changes that to a positive, since a negative times a negative is a positive. And then you've got negative 1 times a positive 2. You got negative 2 out of that. And then the last one, if you're multiplying by positive 1, this is actually a misconception. A lot of people think that if you multiply by a positive 1, it changes all the negatives inside to positives, but that's not true at all. Multiplying by 1 means everything else just drops down. So positive 9x, positive times a positive, positive 2x, and then a positive times a negative, still negative. All right, so once you get rid of parentheses, it's just a matter of using, I don't know if you guys remember this, but it's called the commutative property. The commutative property says if things are added to, I can move them around just as long as I added to or subtracted from. If I keep the negative in front of the subtraction parts, then I can move the like terms together. So, sorry, I kind of butchered that explanation. Bottom line is, if you see an x squared term, the coefficient involved with it too, it can be combined with the other x squared terms because I can reorder negative 3x and negative 3x squared through the commutative property. So I don't need to rewrite it like that. I just need to know that, hey, a negative 1x squared minus a 3x squared, and I believe I forgot a squared on that too. That is totally my bad. Sorry about that. That is going to be in the mix as well. So negative 1 x squared minus 3x squared, that's going to be minus 4x squared. The x squareds don't change. And then a minus 4x squared plus 2x squared is negative 2x squared. Okay. So all these are taken care of. And now you move on to the next term, so to speak. So the next term would be the x's. I'll use a different shape. I'll circle it. Negative 3x plus 4x. It's 1x, positive 1x. Plus 9x is positive 10x. So then those are taken care of, and then we're left with the constants. So positive 8 minus 2, that's positive 6, minus 3, that's positive 3. That's your final answer with that one. Not too bad so far. Moving on to the second example. I'll write it larger so you guys can see it. All right, so in this case, we're not just distributing a positive 1 or a negative 1. We're distributing entire variables or variable expressions, which can be kind of tricky, except we just did the chapter where you multiplied single variable expressions together, which the distributive property is just taking 1 times each individual piece. So all we're really doing here is we're saying, do we know how to take x times 5x squared? Well, we should. We should know that the x is the same as kind of like a 1x, all right? And then when you multiply expressions like this, the coefficients get multiplied. So 1 times 5 is 5. And then x times x, remember, it's kind of like saying, what's the exponent? A 1 here and a 1 here. Well, it's 1 plus 1. It's x to the 1 plus 1. It's x to the 2. Which makes sense. I had 5x, and now I'm incorporating another x to that power. So we're just going to do the same thing here. 1 times a positive 3 is a positive 3. X times x squared, 1 plus 2 is x to the third power. Now with this one, we have a throwback to the last example where there was a minus in front. Remember, you're just going to visualize that as a negative 1. And when you multiply by negative 1, a positive 3x becomes a negative 3x. And then a negative times a negative would be a positive 2. Over here, you multiply the coefficients first. 3 times 2 is a positive 6. X squared times an x, there's a little 1 there that's implied, so it's to the third power. And then 3x squared times a negative 1 just makes positive 3x squared into a negative 3x squared. All right, once you got it to this point, it's just a matter of matching together the like terms because they can move around using the commutative property. The positive 3x cubed plus 6x cubed should give you 9x to the third power. So check those off the list. 5x squared minus 3x squared gives you a positive 2x squared. And then these two can't combine with one another because an x here and a non-x here, it's kind of like saying I can multiply the x times the 2 somehow. It's bottom line is you can't add those two together because they're not like terms. Just like you can't take 9x cubed plus 2x squared and call it something bogus like, I don't know, 11x to the 5th. So what we do is we just say, fall in line, and then our final answer is indeed a new polynomial. So by taking a few polynomials and adding together, you get a new polynomial. All right, let's check out the other examples. This one's a little trickier because you've got double variables in there. You've got an x and a y. The only thing that changes there is you've got more things to manage. All right, so 3xy, you take the 3 times the 1 and get a 3. You take the x times the x squared and you get x to the third power. The y, since there's no other y to work with, you just tag it along at the end. Do the same thing here. Take 3 times negative 3. You get negative 9. You take x times, there's no x to multiply by, so you just put it in the expression. And then you got y times a y. That's going to be y to the second power. So again, I'm just taking each component that matches with either a variable or a coefficient in the next term. So when you see something like 5y times 2x, that's 5 times 2, which is 10. And then y times x, I mean, I could write it like yx here, but I think it makes a little more sense to put it as xy. The commutative property allows us to rewrite it either way. But since we're talking x cubed y, xy squared, seems like xy would be a good choice, yeah. So then we keep going with this. 5y times negative 5y squared, you take the coefficients, 5 times negative 5, negative 25. Y times y squared, that's going to be y cubed. No x's in the picture here. And then you take 5 times negative 3, that's negative 15. The y times the x cubed, just write it as x cubed y. And then you tag along the plus 10y cubed at the end. So now, we're just seeing which terms can be combined. So the ones, here's the thing. You can only take an x cubed y and add to or subtract from another x cubed y. And sometimes this is a better visual for people. If they saw this as 3xxxy minus 9xyy plus 10xy, all I'm doing is expanding the exponents. So x to the third is like xxx. And this is yyyy. This is xxy. And this is yyyy. For some people, that visual helps. They're like terms have to have identical variable parts. I can't combine these two because there's one x here and there's 3 x's there. However, 3x and a y can combine with 3x and a y over here. You don't have to write this step here. I just thought I might just throw that out there for you guys to check out. So the first one I'm going to take is 3x cubed y because it matches with negative 15x cubed y. That's going to be a negative number, negative 12 x cubed y. And then check that off the list. We got it. It appears that the y to the third powers match up. So, negative 25 plus 10 is negative 15. Notice that the powers aren't changing at all. It's still y to the third power. It didn't suddenly become like y to the sixth power or just y. We again have a situation where two things won't combine because one's a xyy, the other's just an xy. So you're just going to say that this is negative 9xy squared, and this is plus 10xy. All right, I'm not going to have enough time to probably go through step-by-step number 4. Why don't you guys try that one on your own, and then I will post, I'll post it in Google Classroom what the answer is to that last notes problem for number 4. All right, thanks for checking this out, guys. Please contact me if you have any questions about this. I usually answer my email from like 9 a.m. to 3 p.m., and I'll do my best to explain whatever questions you have.